So for my senior project, at first I was going to do the rotate lift machine, which we have here, because what I have here is a mock-up assembly line of a motor vehicle company. So it's like, say something you'd find in like Ford or Chevy, takes the car down the line, comes to the first sensor, there's no car here at this sensor. It'll bypass that, come up to the gate. The robot will come over. If the sensor reads a battery there, we'll pick one up, put it in the car, take another one, put it in the car. Laser will come down, weld a couple points on the battery, just simulation, and then the gate will open up, send it down the line, and the next car will come in. Right now, the car will come up to the first sensor. If there is no car here, the conveyor will keep running. As soon as I place the car here, the conveyor will stop, so the next car does not reach the car in front of it. All right, the gripper is going to come down, grab a battery. It'll bring the battery over to this point. If there's a car there, it'll place it in. If not, it'll wait there until a car will come up to the sensor. Yeah, I will. Don't worry. Okay, once that car is in, it'll reach and get another battery. As Mike said during his presentation, he did help me out on this towards the end of the year, so if anything goes wrong here, that was probably Mike, it wasn't me.
Yeah, your mentor's name is Mike, too.
Yeah, well, this Mike, I'm telling you, I owe quite a bit to this guy. All right, the batteries are both now in the car. There's a laser right here on the side of the arm, the forearm. It'll come down, blink 3 times on the battery to simulate welding different points on it. It's probably tough to see from the back, but trust me, it's going on. The gate will come up, the car will go through, and the next one will go down. Since there are batteries still there, the robotic arm will reach over and grab some more. If there's no batteries present in the car, it will sit there and run all day.
With another car, right?
With another car. Okay.
It'll shut it off.
With another car, the conveyor turns off. As soon as the sensor right here on the feeder reads that I put a battery in, the robotic arm will go over and get everything.
So even though nothing was actually moving, the system is still running, waiting for parts.
Miss Klein, what do you got?
Besides the obvious technical skills that you had to have or develop in order to do the project, what other skills have you had in order to be successful?
It's really a lot of problem solving. It's taking it more from, okay, let's just hire somebody, pick up a battery, place it in the car, to how do we get it from there into the car? How do we get it across from here efficiently? Like Scott and, I'm sorry, I didn't get your name. Dixie was saying, it's all about time. You have to get a certain amount of cars down in a certain day, so you want it the most efficient way possible. So that takes a lot of problem solving.
You take that car away now, like not place? It'll place.
It'll place, yeah. Once it makes the sensor, it makes the sensor, so.
Good advocates, guys. No more questions.
Yeah, Jesus.
No more questions.
Put the hands down.
You all the same equipment, the same robot, same conveyor. How could you make that faster?
Well, first of all, I have the robot set to a low speed because like I said, it's not that great. So if I have it going really fast right to place the battery, it'll go past the point that I've set, and it'll probably drive right into the car. So I could probably just sit there and test, see how fast I could get it to go without it actually passing the point. And then, I don't know, maybe run the conveyor faster, and maybe take, instead of 2 batteries, get one large battery so that it'll place it right in. I could optimize my motion profiles.
How does it know if you're not, if you, say you have a battery but there's something wrong with the robot arm, so obviously the conveyor is going to shut down, the one
No.
behind?
No. If the conveyor will run all day waiting for batteries going. Because once the arm places both batteries, it sends a signal to the conveyor that says, okay, I put them in, I'm done. So the conveyor will then open the gate and let the car go through. That's what's gonna happen.
Can you put some more batteries in then and not put another car in?
Yeah. So what'll happen is it'll pick the battery if there's no car here. And it'll get to this point right here and it'll just sit there all day until the car makes the sensor. Once the car makes the sensor, after it's being held, there's a 5-second delay and then the arm will place.
What's the reason for the 5-second delay?
Just so that it gives it time so that we're not getting the car there and then running right into it. So as it's holding, take the car, put it down, makes the sensor, 5 seconds, and then hopefully we'll put it on.
Was there ever any doubt?
Michael O'Neill's my mentor. Jeez.
How much construction work did you have to put into this before you actually started programming?
Construction as in,
Well, you have different parts here.
Like-
You got
like
the
the ramp?
arm, you got the conveyor belt, other pieces.
before the initial programming, all the sub-assemblies, that took a while. I mean, I probably didn't start programming for the last couple weeks of the project, and I worked on it all semester. So yeah, I'd say we had a semester to do the project, so I'd say most of the semester was all just setting up and getting everything aligned and where it should be and building all the ramps and the battery feeder. And the programming was probably the last 2 weeks of it.
What did you use to create your layout? Were you given
Constraints
parameters,
or anything?
or did you use the machine?
Pretty much the
Parameters?
constraints was it had to fit on the table. Really, there was nothing else besides the fact that I had to get batteries into this chassis because I wasn't sure whether to use one large battery or 2 small ones. The 2 small ones worked out better because they were easier to slide down the ramp and so really just the constraints of the robotic arm, the table, and the cars. That's just
So you were given the specs on the robotic arm, or did you have to test that?
I didn't really read the manuals for the different specs. Just I would run what I think would work, and what it would do, I would run, and what it wouldn't, I wouldn't. So pretty much.
There was actually quite a bit of design time,
Yeah.
designing the whole system in the beginning. We spent a lot of time just
Yeah.
figuring out what we're gonna do and then how we're gonna do it.
What's next for you, Chris? What are your
In what way, like school-wise?
ambitions beyond high school?
I hope to attend UMass Amherst.